Today we're taking a look at the WASSP multi-beam sonar technology and having a look at what makes it so different to everything else that's out there. The first thing you'll notice on the screen here is we have some incredible detail that's been rendered by the WASSP. And to understand why we can get this level of detail, we need to understand that it's obtained on our sonar. So WASSP is not just a mapping tool. Obviously a lot of people focus on this incredible detailed mapping, and they're not aware that really it's a fantastic sonar in its own right. So here we have this sonar view looking from port over here on the left hand side right through to the starboard side over here on the right, and effectively we have our transducer up at the top of the screen here, and that creates a 120 degree sector from port to starboard right across below you. So 120 degrees, so 60 degrees off to that side and 60 degrees over that side on the right, making a full 120 degree wedge, shall we call it, a sector. That wedge, that 120 degree sector, is made up of 112 electronic beams. So each of those beams gives you very precise information as to what's going on in the water column within that one beam, and there's 112 of them. So this information allows us to render these truly incredible maps. If we have a look for a second at some of the alternatives on the market, some of the technology that you may be familiar with, maybe this kind of system as represented in this picture here, where we have a traditional sounder, albeit a very good sounder, with a GPS connected to it and a transducer, which is then interfaced to a computer which is running a software package using the GPS for position and the sounder for depth. It creates maps of the seabed. These systems are traditionally quite cost effective, and they're certainly better than having no information of the seabed at all. And what they allow is they allow these one-dimensional images from the sounder to be rendered into 2D or 3-dimensional images on the software package. WASSP is not like that. WASSP is very different. Here we have a WASSP configuration, and now we can see we've got our WASSP transducer, which is this transducer that allows us to view 112 beams, which is connected to a transceiver box, which is then connected to a computer. Also connected is a satellite compass. So this satellite compass system compensates for the vessel movement as it pitches and rolls around, pitch, roll and heave. And then we have two display monitors, and here we have our acoustic information, which is our real-time information we looked at before, as well as our mapping capability. So WASSP is really a sounder and a mapping profiler all in one. And we can see the difference down here. Here we have an example. This is 2 passes over a known bit of reef with a PBG system, and you can see we're starting to see that there's a bit of a shallower shape here. And this is with 2 passes in this image below on the WASSP. After 5 passes, you can see that the PBG system certainly shows that there is structure down there, but it really just shows a big lump of sorts, and the user could be fooled into thinking that this is one big rock. If we have a look now below at the WASSP, you can see that that's not the case at all. The detail that we've got on the WASSP is far superior, and we can start to see into all these little crevices and nooks and crannies and start to make out an image of what really is below the vessel in far superior detail. And we can see this is not a single rock at all. This is really a reef structure. This information can be very, very important to not only your potting type customers, fishing crayfish, crab, lobster, those sort of species who may target these crevices and nooks and crannies, but of course for lining fishermen, seiners, trawlers, they equally may want to avoid the fowl or get as close as possible to it. And this gives a far more precise idea of what's happening below the vessel, eliminating the guesswork And that's why we find a lot of clients traditionally have known that the structure, they've taken the information with a pinch of salt because they've sent a diver down and identified that it actually wasn't one big rock as shown on this PBG image. It was in fact a reef structure as shown on the WASSP below. So the question in there is why is this the case? And to understand this we need to look at target masking. So in my crude representation here we can see that we've got on the left hand side we've got a vessel and it's got a narrow beam, a single traditional narrow beam. And you can see here we've got some fish characters down the bottom, and in this instance we're only seeing one fish in our beam. Now on a traditional sounder what we would get is that we would see this depth and we would see that single fish. We would not see these other fish off to the side because they're outside of the beam. So one would think that having a wide beam was better. However, if we look at scenario 2 on the right hand side here, we can see that the same fish at the same spread. The trouble we have with an acoustic beam is that where it makes contact with the seabed over here, everything below that point gets sucked into your bottom echo, so you don't see it. So this is why fish that are close to the seabed on hills or in crevices, etc., are simply masked. We call it target masking. You cannot see them. So this is why narrow beams are better. But of course if we only had a narrow beam we wouldn't get very good coverage. So this is the secret of WASSP. What we do is we use a narrow beam, but rather than using just one, we use 112 of them. And that's the secret to the success. So if we were passing over the structure we would have a 120 degree swath or sector made up of 112 electronic beams. So we would see exactly what the shape of that hill was, and we would see all those fish on the hill, which is something that traditional down-looking sounders and even sonars to an extent really do struggle with. So WASSP doesn't replace a sonar. That's still, sonar have the benefit of being able to search. A traditional sonar can search all around the vessel, but there is no doubt when you actually get to the fish or over the fish, then WASSP really comes into its own because we can see where they are, the spread off to port or starboard or below. We can see the real shape of the terrain below the vessel. And then through our mapping device we can actually show the history and of the not only the seabed behind us and make maps, render maps, but we can also overlay those fish targets onto our maps to show the spread and distribution. So if we look at this scenario over here, we're looking at part 2 of target masking. Here we can see a similar scenario, this time rather than having a pinnacle as was the case in the previous image here, we now have a gully of sorts or a hole, and here we can see that the narrow beam can see into the hole and we can see that the wider beam can't. Once again, where it makes contact with the seabed, any part of the beam, it will show that as the depth and everything else is absorbed into the bottom echo. So this is why your cheaper, lower cost transducers and sounders cannot see into holes because the beams are simply too wide. Narrow beam is better. And once again with the WASSP, because we've got this 120 degree swath made up of 112 beams, we can see in each little quadrant exactly what's going on in these holes. So here's a crude illustration of this. We can see that with the WASSP, while we're using narrow beams, we can actually cover a much bigger section on the seabed. You can see here on the right through our multi-beam technology, whereas a single beam sounder uses one or two fairly wide beams which give you crude target masking capability and ability to show you rocks, etc. But they also take a very long time to map. So we've got the benefit in WASSP of having preciseness through our narrow beams and coverage through the fact that we have so many of them. So now we're going to have a look at a calculator that we've made. This calculator is available on our website, and here we can see in certain depths we can see the coverage of the swath. So in 100 meters of water through a 120 degree angle, we can actually map below the boats and see below the boat 346 meters at the seabed level. That's our area of coverage, and obviously the deeper you go, the wider this coverage is. So in 150 meters water depth, we're profiling a corridor along the seabed, both acoustically and with our mapping, 520 meters wide. So that's incredible coverage. Now, a lot of people struggle to put that into comprehending it in real life scenarios. So I'm going to give you an example. Here's the calculator on our website, and we can choose a depth. So we'll start with a shallow water application. Let's say we're in 40 meters of water. Our WASSP beams are 1.2 degrees. A traditional sounder, a good sounder on 200 kilohertz would have a 5-degree beam, so we'll put that in. We're going to search an area of 1 kilometer by 1 kilometer grid, but you can decide what you want. And then of course the vessel speed will have an impact on how quickly we can map it out. So just to recap, we're setting a depth of 40 meters. We're comparing the WASSP, which has got 112 beams at 1.2 degrees each over 120 degree swath sector, and we're going to compare that with a single beam sounder with just the single beam, which is 5 degrees wide. We're going to map out an area of 1 kilometer by 1 kilometer, and the vessel's going to do 6 knots. So let's have a look. Basically, our calculator shows us that the WASSP coverage on the seabed is 136 meters wide and 40 meters of water depth, versus the single beam has a footprint on the seabed of 3.49 meters wide. In terms of how long it will take to map out the area, the WASSP would take 40 minutes to map out that 1 kilometer by 1 kilometer grid, versus the PBG system would take 26 hours. The WASSP would require just 7.4 tracks over that 40 minutes versus 286 tracks over that 26-hour period it would take the single beam sounder to map it. And here's the big but. The but is, you can see under the precision, the WASSP in 40 meters of water depth, each of those beams is profiling to 0.84. That's less than a meter resolution versus 3.49 meters on the single beam sounder. So here's the secret as to why we can draw those nooks and crannies, because there's a hell of a lot of averaging going on this 3.49 meter beam width. You can imagine any nooks or crannies that are narrower than 3.49 meters, you're simply not going to see into them. So it's going to draw the seabed as not having any hole where there really is a hole smaller than 3.49 meters. And additionally, if you are near to the rock but not actually on it, if any part of your beam is touching that rock, it's going to say that you're on it. So there's an element of misinformation because of the fact that this data is not very accurate. So at this point, some people may think, okay, this is a great product for shallow water fishing, but let me just show you something, because in deeper water the effect can even be more exaggerated. Let's say we're fishing in 400 meters of water, which is a fairly common depth for performance leisure fishing or commercial fishing, and these guys will be using a beam that's maybe around about, we'll give them the benefit, about 17 to 20 degrees if it's a really good sounder, out to 40, 50 degrees if it's a low-end leisure sounder. So we'll give them the benefit of the doubt. So we're going to look 400 meters water depth. I'm going to compare the WASSP, which of course still 1.2 degrees, versus a single beam sounder at 17 degrees. And I'm going to search out, let's make it a challenge. We're going to search out a 10 kilometer by 10 kilometer grid. We want to really break in some new territory. We've never been there before. And the vessel speed will leave at 6 knots. So in 400 meters of water depth, each pass of the WASSP will be 1.36 kilometers wide. Just incredible. That's how quickly you can map an area. So as you move along, your corridor that you map on the seabed will be 1.36 kilometers wide in 400 meters of water. The single beam transducer, however, has a footprint coverage on the seabed of basically 120 meters, 119 meters. So we're getting better coverage on our single beam transducer. However, it will still take 75 hours and 84 tracks to map out with a single beam sounder that 10 kilometer by 10 kilometer grid. And instead of 75 hours, it will take just 400 minutes to do it with the WASSP and 7.4 tracks. So you can see just how much faster, 400 minutes versus 75 hours to search out that area. And this is where a lot of our clients are giving us feedback. They're able to break in new territory faster than they ever had before. and it really makes it viable to go out now and do more hunting and prospect on unknown territory. Here's the big but again, the seabed precision. So the WASP, each footprint on the seabed is 8.38 meters, which is pretty respectable in a 400 meter depth, versus the single beam footprint is 120 meters, which doesn't sound too bad, but when you consider that's bigger than a football paddock, football field, then really it does bring into question how reliable that information is. It's very likely that there are bits of foul that are appear within that 120 meters. Is likelihood to be dips, holes, gullies within that 120 meters, and all of which you're going to miss. You won't get that detail on your traditional single beam sounder. So if you're the type of fisherman who's targeting species on hills and in gullies and hidden in nooks or crannies, this is where WASP really has the advantage. It will show you the seabed to the best possible detail of what it really looks like, and it'll show those fish targets where other traditional down-facing sounders and PBG programs simply won't. And all of this culminates in being able to provide you with this absolutely incredible level of detail. And not only do we have the ability to show you the mapping, but because it is an acoustic sounder, we can actually overlay our fish targets too. And so they can be represented here as an overlay, and we can view those in 3D. So there simply is nothing like WASP. It's taking technology to a whole new level. If you would like any more information on anything you've seen in this presentation, please visit our website www.wasp.com. That's WASSP.com. Thank you.